Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the matrix labs, the video number 103. We have been discussing in the previous video the following. While still working with the subject or the topic of troubleshooting and repairing Windows operating system using SFC and DISM commands. We have seen the different AI tools generating different scenarios, how we can use SFC and DISM to solve corrupted operating system files. We have seen how these scenarios are creative. We have seen, for example, Gemini experimental 1206 generating some useful and good examples, and we have seen also Gemini 2 experimental thinking also generating some useful scenarios. We have seen I think we have seen some scenarios from ChatGPT, or I think now ChatGPT, and then we currently in the previous video stopped at a scenario generated by Claude, and we will continue working with this scenario. So if we go there and see, here we have a scenario. We have multiple users in the accounting department. 20 users report that after a recent Windows update they cannot open Excel files and get errors about missing DLL files. Some users also report that Windows update is failing. We have seen here that we have a couple of things done. First, we run SFC to make sure that we don't have any corrupted files. If we have corrupted files and was not fixed, we need to run DISM health restore and then run SFC again. Okay, uh, this is uh, this is how should things be done. But here the senior IT, so this was the answer of the junior IT. As for the senior IT, he gives or he give the junior IT a script to automate these steps on 20 PCs. So here, if it works on one computer, we would create a script to run these on all affected machines. So he will run a script to run SFC and DISM and run SFC again, so it can fix the issue. Okay, and he enhanced the script by adding a couple of things. So for example, here is the script. We need to run it on all of our 20 affected machines. First of all, a checkpoint to what we do. This line, it will create a system restore point before further changing any system files or replacing any system files. Then we run SFC, then we run check health, then scan health, then restore health, then scan now. So this is a script we can run on all of the affected PCs. Okay, and this is the simple, or this also is introduced by the junior IT. The senior IT will add a couple of things to this script. So we will see now, for example, that he will give us this script. This is multi repair script. If we go there and see what this script will do, we can see, we have seen in the previous video that we have given ChatGPT 03 this script, and it analyzed it, or it give us a hint about what this script will do. It will you should introduce to it or give the script a text file that contains the accounting affected PCs, and then we will create a share folder on the file server which is called repairs logs. It will get the Windows update log for each of these PCs that was listed in the text file and put it on a share folder. Okay, here we go. This is get Windows update log for each PC, and then we create a restore point for each PC, and then run system file check and log results. Okay, this is it. And then after that, we number 2 function to check system file health. Okay, so all of these are the steps of the script. Okay, at the end, this script is more advanced than the one the junior IT introduced. You see, we can see, for example, here we have the function to check system files or system health. So I think if we go further from the beginning here, run system file check. So this will run the system file check, okay, and it will log the results. Okay, if it is fixed, okay, If it's not fixed, then I think we will go to the next step, which we will run DISM online cleanup health check, and also I think this will be maybe logged. Okay, so let's see after that. So we run health check, and then he will go to function to repair system files. Okay, and then SFC scan now. Okay, run DISM if needed. Okay, so here he will run SFC if needed, run DISM if needed, and then at the end run SFC again to verify. Okay, and at the end repair process is complete. So I think this uh, script should be tested in a virtual environment to see if it's already working perfectly or not, and this was introduced in the answer of the senior IT. If we see here, he will ask, or we have stopped the last time, would you like to set up a test environment with a few VMs to practice this scenario? So he need to create virtual machines and run this script on it. Okay, so here we have stopped the last time at this step. So here we can see junior admin, yes, I would really like to practice this in a test environment. From what I understand, we should set up a few test VMs running Windows 11 to simulate the accounting department computers, create some problems similar to what we are seeing, missing DLL files and Windows Update issues. Try running the script to fix them. But I have some concerns. How many test VMs would be good to start with? Should we intentionally corrupt some system files to test the repair process? The safest way to simulate these issues without causing real damage. Uh, how do we know if the script actually fixed everything? So we have senior IT admin. Good questions about the test environment. Let's set up properly. Initial test environment, set up 3 Windows 11 VMs. We have VM control, clean installation, VM2 test machine with SFC issues, test machine with deeper DISM issues. Safe way to simulate. Here on VM2, we need to create some problems with some DLL files to see if SFC will repair it. Here we can see, for example, there is another way that we can corrupt some DLL files by just renaming the DLL file. We have seen that Gemini have provided us with another way to corrupt a system file by playing with some bytes or bits in the file itself. Something like corrupting some of the components of the file, internal components of the file. Okay, here we only just rename the DLL file, and then on VM3 create component to store issue DISM online repair reset base. So the interrupt the process, simulate corruption. So here another way we can have some issues with the or create some issues to corrupt the files in the WinSSX folder by running this DISM commandlet to clean up old files in WinSSX, reset base, and disrupt or just cut the operation suddenly. So this will do a damage to the WinSSX WinSSX files. So these are two ways to create some problems. Then after that verification step, we need to, after doing the corruption, we need to run SFC verify only and DISM health check. So we need to see or to run this on the second virtual machine and run this on the third virtual machine. Then we check Windows Update log to see if there is any errors. Okay. Would you like to start up setting the first VM together? So here we will set up the first virtual machine, and then we can continue with our answer. Here we need to install a clean Windows 11, take a snapshot before doing anything, join it to our test domain. Okay, for VM2 we will set up the same way, rename the DLL as you mentioned, take a snapshot before and after creating the issue. For VM3 initial setup, try the DISM command that simulates corruption, take snapshot at each step. But I am a little bit nervous about interrupting this process on VM3. Would that cause real damage? And how exactly do we safely interrupt it? Also, should we install the same Windows updates on all VMs to keep them consistent? A good note. Senior IT admin, good thinking about the snapshot and consistency. Let me address your concerns and add some important details. Windows repair test environment setup. So here we will see how he will uh, make this. As we can see, the answer is very intelligent from my point of view. It's creating the answer and the environment to implement his answer. So we can see base VM setup, all VMs, initial configuration, Windows 11 Pro, 4 GB of RAM, 60 gigabyte free space, network internal switch for isolation. So he is preferring this uh, machines not to get to the internet, so this will be a problem when we apply the DISM repair. So network isolation, a snapshot strategy, snapshot for the first VM, clean installation, snapshot strategy, clean installation. So we will take a snapshot on every virtual machine after the clean installation, after Windows update, before creating issues, after creating issues. So here the snapshots here is not referring to the system restore point, uh, which is better. You can take system restore after every step of the way, and you take a snapshot from the hypervisor software like Hyper-V or VMware or VirtualBox. So this is just to be cautious. If anything happen, you can repair or you can return to the previous step. Okay, so again, this is good steps. VM specific configuration. We have VM number one, control purpose, clean reference system, configuration, standard Windows 11 installation, all updates applied, no simulated issue. As for VM2, SFC test, purpose test SFC repairs, safe issue creation, we have seen this. We will copy. So here is adding an extra step. We will copy the original DLL, so we'll copy it from C to another one and just rename it to return it back after corrupting it, and then we will rename the file. So it just take a safe copy, create backup of the original file, and then rename file to simulate missing DLL. So very good answer. Now we have VM DISM test, purpose test DISM repairs, safe issue creation, method 1 safe component store corruption, DISM online cleanup, start component cleanup, then manually delete some component store files. Safer than interruption. So here is introducing another thing. We should not interrupt the process, but after the process is finished, we can delete one of the files. Can we do that? We will have permissions to do that. I think maybe we can. So after that, or method 2, create pending XML issues, rename XML pending. What is the pending XML? This is another file. I don't know what is the purpose. So if we rename this file, what could it do exactly? So let's see. Also, this is one thing I need to ask, for example, Copilot or other AI tools to see what is the effect of doing something like that. If we go there and ask Copilot, so as we see, the answer is very rich. We can see it contains a lot of details which will not be introduced if we ask the AI tool to uh, explain the topic directly. What does this script do exactly, and what is pending .xml file function? So let's put like this way and do like that. Let's just delete this line. And let's ask this question to a couple of AI tools just to make sure what is this file exactly. Let's do it like that. Okay, let's see this. Saying that is often done to resolve issues related to Windows updates. The pending file is created by the Windows Update process. It contains information about updates that are pending installation. If an update fails or gets stuck, the pending XML file can sometimes prevent further updates from being installed. So he's referring here to some references for this line. Renaming or deleting this file can help resolve updates issues by allowing the update process to start fresh. Okay, so this is one thing. There is from answers from Microsoft. I'll say we have two answers here. Let's see this one here. So this is answers. So I think this is good. Deleting. So here is saying this is from Microsoft answers. So after ignoring, I have found myself. So after a while of ignoring failed Windows updates, I have found myself with a full sea of pending files. I've tried few commands as an admin to try and remove these files, but kept cannot find. So my drive is full because of them, and all I need is to get rid of them. So okay, this is it. So okay, so the command try to remove SS folder, clean up start component. Okay, so this will help to solve something like that. So this is a clever way because we can use the same command to repair or delete the pending file. So we can rename it and then we can do this to repair it maybe or delete it. Let's see if this can help actually. Okay, and we can see okay, so here how he solved this issue. Don't try to delete anything directly from SS folder. You can download this tool and run command 10 this issue DISM to clean SS folder. So reset Windows update. So scan SFC, DISM health check, restore health. So we can repair it in a couple of ways. We can restore health just to do that. Okay, so we have a couple of things. Where is another answer? Let's see if there is another answer containing this one. Troubleshooting Windows 10 due to pending.xml. How was okay? Not working properly. Okay, so okay, so this seems to be an answer, but I need to have more confirmation concerning this one. So I will go and ask Perplexity to answer this. If we go and go to Perplexity, here is Perplexity AI, and try to see if also he will give us a valid answer. So we can put like that and do like this. And let's, where is the, he was giving us before that pro, so why he is not giving me the pro thing here? Pro, okay, so he has just changed the interface. Okay, pro, and then let's see. So let's see also what is the answer here. To rename so on. So function of pending. This is a critical component of Windows system that store information about pending operations related to Windows update and installations. When updates are downloaded and prepared for installation, Windows create this file to track what actions needed to be completed during the next reboot. If update process is interrupted or failed, it can lead to situations where the system perpetually believes that updates are pending, causing boot issues or repeated update attempts. So the same answer from for same answer like Copilot. So renaming serve several purposes: clearing update flags, okay, troubleshooting boot issues. If a system is stuck in a loop during to apply boots, renaming this file can help restore boot functionality. It allows user to troubleshoot further without being hindered by the process updates. Very, very good. Okay, for I think this is also one of the things we can learn from a process like that. Backup. Renaming instead of deleting provides a safety net, so we can return to it. Context of use. The command is used in troubleshooting scenarios where system fails to boot you pending updates. User experiences repeated failures during update installation. This is a need to reset the update state without performing more enhanced recovery options. So we can go and see. So now we are creating a problem with one of the important WinSX files. Safety measures. Never test on a production system, always work from snapshots, keep good documentation of changes, use internal network only, maintain separate backups. Okay, verification steps. Now we need to, after doing the corruption, we need to run SFC, verify only, not to repair, and we check the health of the DISM, and then we need to export Windows update logs. Okay, okay, so I think this will, from it we can see after renaming the pending or something, maybe there is a problem with the Windows updates. Anyway, let's continue and see. Think performance balance or baseline. Create performance baseline. Here, what this he will do, counter system. Why is this? Why he's creating a baseline? The baseline from the clean VM, which is VM1. Let's also see what this will do. If you copy that and let's go this time and ask what does this script do exactly in simple terms. He's doing some measures. Let me do like this and see what this will do. If we go and ask it to explain this script. So here the script collects data. It uses get counter command to gather all system related performance metrics. Take 60 samples. Parameter set to collect 60 data samples, effectively capturing performance information over a period of time. Export. The data is exported like this one. So save 60 performance saves to a file, creating performance baseline that you can later to compare against future system data. So I think this will run. He will run this on the first VM. Okay, I think this will run on the first VM. Okay, clean reference system. I think this will run on the first one. Anyway, so let's continue and see the other steps. So as we can see, very, very logical steps and actually professional scenario from my point of view. Recovery procedures. If VM becomes unbootable, revert to the last good snapshot, document what caused the issue, try alternative methods for issue simulation. If repair fails, so he's giving you situations after simulating the corruption, and if it didn't work, SFC didn't work to repair it, or DISM, you can return to the last known snapshot. If repair fails, collect all logs, document exact error messages, revert to clean snapshot. So this is our two situations we can benefit from. At the end, testing workflow. Start with basic test on VM2, progress to more complex scenarios on VM3, document all commands and results, practice recovery procedures, test repair script functionality. So as we can see, very, very good steps to simulate a problem and use the script to solve it. So this is how we can do something like that. So uh, so another thing here is saying your concerns about DISM interruption are valid. Let's use a safer method. We have seen this to rename the files. And for consistency, create a base image with all updates, clone it for each VM so all of them have the same updates. Take snapshot at key points. Okay, so this is good. Would you like to start with VM2 and the SFC testing first? It's simpler and we will build confidence before we move to more complex this. So now we have already the scenario. We need to begin with VM2, okay, to begin our scenario. Yes, start with VM makes sense. For the DLL issue, we can practice restoring it in both ways, using the backup we have created or using SFC to restore it. Okay, let's see. That's where I can see SFC actually replaces the corrupted the file compared to a manual restore. Excellent suggestion. This is exactly the kind of comparative testing that helps build deep understanding. Let's add some monitoring too, so you can see exactly what SFC do. So we will do start process monitor to watch file system activity, run SFC and watch it work with DLL files. So the process monitor, he is talking about this commandlet maybe. So he is talking about uh, VM2. So I think this line is on VM3. Okay, he need to have a start a process monitor or VM2. How we can do that? He didn't give us the step. Run SFC and then we can analyze the logs. So this is a good way. Okay, ready to start with VM3. Okay, VM2. Okay, I'm ready to set up. So here I should create a new VM. Okay, we have seen all of these steps. Install Windows. Take my snapshot, label it clean setup, clean install plus updates. Uh, Create the test issue. We have seen this step. Take another snapshot. So DLS. Okay, so this is the steps. Monitor and fix. Start process monitor like you mentioned. So how this is done, I don't know how he will start process monitor. Maybe he is monitoring from the task manager. Maybe I don't know. Run SFC. Check the logs. Uh, am I missing thing? And how do I know which events to look for in the process monitor? There might be a lot of activity to filter through. So here is how we can have a process monitor during our SFC repair. So let's see also this one. And why it is important. He's saying that why we need to monitor the process. Okay. Let's, because he was saying that in his answer. Let me see here. We have practice. Why we need to see the process monitor. Here is saying that comparative building. So okay, let's add some monitoring too, so you can see exactly what SFC does. So through the process monitor, he will see exactly what is the SFC is doing. How is that? Let me try to see the our process monitor setup for SFC monitoring. Let's see what is the answer. If we go further, open process monitor, press Ctrl plus L to open filter window, add this filter, process name SFC, process name trusted installer. This is related to the Windows update, and this is the file that we have renamed. Operation is create file, operation file is write file, operation file is read. So all of this is done using the process monitor column configuration. So we are monitoring the process of the SFC through a process monitor, trusted installer. All of this we need to monitor it. Column configuration, add these columns, process name, operation path, result detail, monitoring setup. Before beginning SFC, clear all events, enable capture. Okay, so he's capturing the process of all of these, a live capture. Note current time. During SFC, run the elevated command, watch for trust installer activation, file of trust installer. I think this maybe it will repair, because this is the only one responsible for repairing or accessing protected files in the WinSSC folder. Okay, maybe this one is used to get the healthy file and replace it for the operating system files. File operation on this file, access to WinSX folder. After SFC completes, stop capture, save log, and then log analysis. This is for uh, save log. This is for the monitoring log. Okay, log analysis. We will check the CBS log. Process monitor analysis. Look for these patterns: initial file verification, backup creation, file restore, verification, check. Verification steps: check file integrity. So after changing the file or replacing the DLL file, we need to check the algorithm, check the file hash to make sure that this is the correct file. I don't know how we will compare it, or how we can know that this hash is the correct one. I think we should compare it to the same file on the VM1 or the healthy LC virtual machine. Okay, I think this should be file permissions. Okay, verify system operation, check event viewer, run test applications, verify Windows update works. So I think this file is related to Windows update. Maybe what is this file actually? What is this DLL? Why he choose it to corrupt it? What is this file? Let me try to copy and ask also again what is this file function, and let's see if this will help us to know what this file does exactly. So let's see, this file is a dynamic file that comes with Visual Studio. It contains the implementation of many standard library functions, as those for input and output memory management. Application developed by Visual Studio you need in order to run properly on your system. If the file is missing or corrupted, programs that depend on it might not work correctly. Maybe uh, is this file related to Windows Update? Maybe this is why he have corrupted it, related to Windows Update process. Let's see what will be the answer. No, it's not directly related. It's a component of Microsoft, so maybe applications run it. Although update might occasionally update these libraries if a new version is released. The file itself is not a part of the system. Okay, so he's just corrupting one file and checking it. So we can see a very useful exercise and more dynamic from my point of view than the answer of Gemini. Let me see if we press Control L. So we need to have the process monitor. What we need Control L. Let me see. We have to have the process monitor. Where is the process monitor? I think we can from here get the control panel. We have maybe from administrative tools. We have the process monitor. So here it is, the performance monitor or the process monitor. So this is different. We have process monitor. Okay. The process monitor. Let's see where is the process monitor. Copy and Windows process monitor. So this is one of the Windows Microsoft sysinternals suite. I have already one of these, and we will explain it later. uh, because this is very important tool. We have the process monitor, I have it already. So if we go there and see the process monitor, I have already it there. Let me show you. So I have it, but we'll explain it later. We have Microsoft Sys internals. Here you go, we have Microsoft. Okay, I think it's in the matrix final. We have Microsoft. I have it already, I remember. I have Sys internals, Sys internal suite. We have process. We have the process mon. Okay, here it is. This is the one. And we can run it like that. So you can see here we can monitor it like Control L, capture events by Control E, and capture Control L to remove all of the things here. So here we go. This it will monitor. I think we can monitor something like that from this application. So, and I think now he is capturing. So if you need to stop and remove, so now we can remove everything. Okay, X to clear, Control L, and remove everything. So this is one good thing. We will use it later anyway. So this is, even though it was not, he didn't state that this is not a built-in Microsoft application, but he give us the name. So this is a good thing anyway. So we can see now that he is giving us the steps before creating the issue. Document the original file hash. So here is another thing why he is getting the hash. So before making the repair, we need to get the hash of the corrupted file, and after repairing it we need to get the hash of the healthy file to make sure that it is already repaired. Note the original file permissions to make sure also that the permissions are the same. We didn't play with the permissions. I don't know why this step is included. Maybe if we need to play with it, we need to, or to corrupt it, we need to change the permissions. So this is a good thing. Create a baseline system performance record. This is what we actually do in the step before it. We have already a system performance record. Okay, so after creating the issue, let's continue. Take a quick screenshot of any error messages, note which applications fail, document in your test log. During repair, use the process monitor filters I provided, watch the trust installer service activate, note how SFC reads from WinSX folder. Okay, so we have seen all of this. Okay, now what we need to do, ready to start the actual VM creation. Yes, the process monitor filters makes it a lot more sense. We're especially watching for SFC and trust installer because those are the processes that do the actual repair work, right? And watching DLL file operations will show us exactly how it gets replaced. Should we also monitor memory and CPU usage during the repair to see how resource intensive it is? This is also a good point. That might be helpful to know for when we need to do this on user computers during working hours. So the process monitor, so I think we need to do other things. So here is giving us a very detailed situation. I think this is very good from my point of view. Okay, junior IT, for monitoring system resource during the repair, I think we would use performance monitor to track CPU usage, memory usage. This activity might set up some alerts if goes too high. For the actual setup, we will do that. We will go on the virtual machine and do that. The process time, the memory available, and the read disk or the activity on the hard disk, and this will be export as repair baseline. Okay, and we will run the process monitor during the repair process. I'm not sure how often should we collect the samples, what numbers are the normal versus concerning. Will running process monitor at the same time affect the performance data? Good thinking about performance monitoring. Let me help you set up some comprehensive monitoring approach. As we see, the scenario is getting deeper. Okay, we are now getting deep, deep, deep. The first thing we need just to fix some problems concerning some accounting PCs, and now we are replicating the issue on a virtual environment, and now we are trying to monitor the process through the process monitor, and then we are concerned about the performance of the repair. It will get intensive. Maybe we need to make the repair while the users are working off or during off working hours. So these are all things legitimate to think about. Let's see the performance monitoring configuration for system repairs. As we can see here, this is also a performance counter. This is a PowerShell script. Create data collector, system repair monitoring, and then start collection. So this is very simple. As we can see, these are different data sets or data collector sets or counters. So this is good. Okay, so we'll run this along with the process monitor during the repair process. Okay, so your question were spot on. Here are the answers. Sample frequency. Every 15 seconds is a good for general monitoring. Captures spikes without overwhelming storage. So every 15 seconds wouldn't significantly impact performance. Normal versus concerning numbers. So he's giving us a little bit of something here. Normal is 20 to 40. Concerning above 80. Memory should have at least 2 gigabytes free of space. Disk queue should stay below 2. So all of these are the normal things, and our collector or our performance monitor, if we have above 80, then this is critical. If you have using memory, uh, should have at least 2 gigabytes free of space, memory space. Disk queue should stay below 2. So let's see, process monitor impact. Yes, it will have some impact, so this we have some concern. Use filters to minimize overhead. We have filters already. You can exclude process monitor from performance data. So we can uh, uh, exclude process monitor from performance data. Okay, so this is good. Would you like to set up these monitoring tools and do a test run to see what normal looks like on your VM? So he will try to use this counter on our healthy VM to see the normal standards. Okay, to see the normal process. Okay, so he's looking on your VM. Yes, it would be helpful. The script looks much more comprehensive than what I was thinking. I see it monitors trusted installer specifically. Is that because it is the main service that does the repair? Okay, for the test run, should we run it on a clean VM? This is the one. We will take this script and run it on the clean VM to get a baseline, then run it while we create the DLL issue, finally run it during the repair process. Okay, so okay, but we don't need to run this during the create the DLL issue. I think we should run it on the clean VM and then run it during the repair process. Okay, so see the difference in resource usage at each stage. Excellent approach. You are understanding the methodology perfect. Yes, trust the installer is the crucial to monitor because it is the service that actually performs the repair. It has specific resource requirements. It's not functioning properly, repairs will fail. We all know the trusted installer, it is the one that the only have access to a WinSSX folder. So we cannot do anything unless this user is responsible for doing that. Let's start with your baseline test. Remember to document every step. It will be valuable for our knowledge base later. Ready to begin. Okay, so let's ready to start the baseline test. Here is how do we plan. On the clean VM, we will first clear any existing performance logs and then start monitoring with those counters we provided. So we will run this we'll take that and run it, okay, on the clean VM. Then let it run for maybe 10 minutes to a good baseline. After that, create the DLL issue okay, on the VM number 2, okay, and also run the same collector on the VM2. And should we try uh, use the system normally during baseline collection, or how do we make sure trusted or isn't doing anything else during our test? If the repair fails, will these logs help us understand why? So let's continue with the answer here. Let me enhance your plan. For the baseline, uh, first check if SAS install is idle on the clean VM. Okay, stop any Windows updates. So he is, as we have seen, the trusted installer is responsible for updates. So he is suspecting maybe there is an update during the performance monitoring. Monitor this trusted installer, so we don't make sure, or we make sure that the trusted installer will only work for the repair process, not for a normal Windows update process. So here is stopping all of the Windows update services, create our data directory, start our enhanced monitor, start collection. So this should be done on the VM clean VM. So we need to make sure that trusted installer is idle. This is the good thing because trusted installer is used for normal Windows updates. So before running this on the clean VM, we need to make sure that there is no Windows updates, or we can stop the Windows update service and uh, completely, so we are sure that trusted installer is only working, or we are monitoring, sorry, we will not, we are stopping it to make sure that we are only monitoring trusted installer uh, uh, during the repair. It's idle, so we are not taking the performance monitor while the trusted installer is working. We need to make sure it is off because this is the standard or the normal one. We need to check if such installer is idle and stop all the Windows updates to make sure we have a clean sets of data. Okay, then we can go and continue. Okay, during baseline collection, run common applications, browser and office, open and close. This is all on the clean VM. Run at least for 15 minutes. This gives us a realistic baseline. For repair monitoring, keep logs for each stage. Monitor event viewer in real time. Save all CBS logs. So we go to the clean VM. Okay, before running this performance monitor sets, we need to make the trusted installer is not working, stop it, then create the counters, and then begin working normally, opening browser and office and some applications, run it for 15 minutes, and then we have a real baseline. Okay, so this is on the clean VM. I think now we have thing, but this should run on the virtual machine 2. Okay, DSL issue and monitor, this is not on the normal VM. Okay, so again, even though it seems to be a little bit not in order, but we are, I am working with it. Okay, would you like to start with checking trust installer current status? Yes, we should check trust install first. I notice you have added stopping Windows update service. Is that because they might interfere with our testing? And we should create a system restore point 2 before we start. We have already a snapshot just in case something goes wrong with the test. Yes, to both, always better to be safe. Let's add these steps. So we will create a restore point on the VM, clean VM. Then we get all of the check and stop these services, verify Windows installer if it is running, and then get Windows installer investigating. So should, oh, okay, so after stopping the services, the trusted installer will not work. Yes, so right, restore is running, investigate why. So the trusted installer will not work if these services are down. Okay, and now we have this done, and we will stop it. We will stop, and it will record this in the event viewer. Okay, so this is a good thing. So all of this to make a baseline, a good baseline before performance testing. Okay, so everything is good. Let's continue. Okay, admin Jerry, let's run these commandlets. I will do them one at a time to make sure I understand what each does do. So we have the checkpoint, okay, and then we will have the get services, checking services, then we're checking the trusted installer. I see the trusted is running. Should we wait for it to finish whatever it's doing, and how do we know it's actually doing right now? Good, careful approach. Yes, if the trusted installer is running, we should investigate. Let me add some more details. So get more trusted installer information. So what we should do, okay, check what files it is accessing. So if you, after doing all of these steps and stopping these services and still trusted installer is running, then we have to make sure what he is running exactly, okay, or what he is accessing currently. Okay, check what it's accessing. Okay, check pending operation. Syst has pending reboot from previous. Maybe there is some updates that need a restart, so we need to restart the PC so the trusted installer can finish his operation. Okay, this will tell us how long trusted has been running, what resource it's using, what files it's accessing, if there are any pending operations. Okay, so this is good. Yes, let's run those additional checks. I am seeing now from the output trusted installer, so and so, check files, module list output, warning, system has pending reboots from previous operations. Okay, we have a pending reboot. Should we document what we found in our test log? Reboot the VM before proceeding, then start our test. So I think we can document and then restart the VM and then begin our capturing process, our performance monitoring process. I noticed that the memory seems high. It's 144, 145 megabyte normal. For trust installer, I want to make sure I know what the normal looks. I can spot problems in the future. Okay, good observation about both the pending reboot and the memory usage. Let's handle this systematically. Let's document what we have found. So we have the performance monitoring. I think the trusted installer will get much of the memory because there is an Windows update process working. So this is a good, or this is logic. Let's see, reboot, so and so, handle systematically. Okay. About trust install memory usage, normal range is from 50 to 100 when idle. 145 is actively working, can spike to 200, 300 during repairs. Okay, so if there is trusted installer working with 145, then this seems to be there is an update process. Can spike to 20 to 300, 200 to 300 during repairs. Yes, let's do a clean reboot. So very actually astonished. After reboot, we should verify test install is idle, check memory usage again, then start our baseline collection. Okay, let's proceed to the reboot. Okay, let's proceed to the reboot, but first let's make sure I have got everything logged. Okay, so adding final notes before reboot. Okay, so we have a log. First install was running with high memory usage, pending reboot detected, stop services, system restore created. So all we have done on the clean VM. Restart. Okay, and then we should check the trusted installer again, verify all services are stopped, check memory. Okay, this is the right sequence, and we should have wait a few minutes after reboot before checking or let everything settle. Excellent detail when logging. Here let's enhance our post reboot sequence. Okay, so wait for system to settle. 5 minutes is a good practice. So after restarting we need to wait for 5 minutes and then begin logging. Post reboot system check, and then system state. We need to see the trusted installer and all of the services. We have already stopped them, and see trusted installer if it's not working now. Pending reboot. This is, I think, a registry key where we can know if there is any pending reboot from this registry key, which is very good, by the way. There is also a lot of useful information, but I think let me see something just to make sure that this already is there. If I try to go to this registry key Is it there already? Because this is seems to be uh, fantastic. Okay, let me see regedit and see if we have a registry key like this one. So if we go there and try to see if we have something like that, maybe we have something like this. If we get control V, let's control V, and let's see, here we go, this is the software maybe. So I think software, maybe this is like this, pending reboot. So let's see, okay, again, let me see. This is the local machine. Okay, so let me see, or let me try to get it. This is software, Microsoft, Microsoft Windows Update. So, okay, software. Okay, let's go to get it from the starts. So here is software. No, this is in the system. So we have software, and we have Microsoft, and we have which one? Windows current. Okay, so we have Microsoft, then we have Windows. Let's go further deep. It's Windows, then we have current version, and then we have component based servicing. Okay, and we have, surprisingly, we have session pending, or I think this is one. Let me see. We can continue component based, and we have reboot pending. Where is the reboot pending? I don't see a kind of registry key. Update detected, maybe session pending. Cross reboot result, maybe this is it. We have features on demand, so we have component services. We have something like this one, maybe driver operations, packages, session pending, update detect. If we go further, no. So I think the most logical one is session pending, maybe. Cross reboot result, maybe this is it. So he's giving us a fake let me see. I'll try to do something here. If we go this one and copy, maybe this is our older version systems, or let me try to put this. Let's see if this uh, is this key correct. So this is it already. This is there, but actually I don't see it in my installation. So it is there, okay, but actually I don't see it. Maybe this on Windows Server. So he's saying that this so this, it is on 20. Okay, let's see. So it is there, so he is not faking it. Okay, so reboot pending, it is there. Okay, post reboot pending, so it is there already, even though I don't have it or I don't see it. So okay, I can confirm that his answer is correct. So let's continue with the answer. So again, now we have everything logged. Okay, we have everything monitored, log the results. Okay, and after that, ready to run this after the reboot. Also notice I have added memory checking. This gives us a good baseline for system resources before we start. So after we restart, we will run all of these to make sure that our trusted installer service is not working and everything is stopped. Okay, so we can continue. Yes, let's make a system reboot looking for the results. So after that he will run this one. We have the status stopped, we have services stopped, we have pending reboot false, we have free memory 6.32. So this is good. We can now take our baseline. We'll begin working with our baseline. Okay, use this system normally for 15 minutes like suggested, then create our DLL issue. Okay, should note that down what normal usage look like before we break anything, like write down the typical CPU and memory usage. Okay, he needs to write it down. Okay, let's perfect. Let's create a proper baseline record. Here we can enhance our monitor. We have the CPU, so create a baseline snapshot. So he's doing that. We have already done this, but he will put it in. Okay, so he will log them. I think he will take all of these and log them. Log baseline data. So I think he will log it in a file. So correct. He needs to have not only the log file or performance monitor log file, but also put it in a text file just to make sure we have everything recorded. Start the enhanced monitoring. So okay, so we will do that. This will create a detailed baseline snapshot, monitor system for 15 minutes, save it in CSV for later comparison. While this runs, use the system normally. Open and close applications, create and save some files, browse some websites. Okay, ready to start this enhanced monitoring. Okay, let's start with the enhanced monitor. I see that you did. Saving it to CSV will make it easier to analyze later, so that's good. We will run the commandlets. Okay, then he is analyzing the script. Initial good looking. We have CPU 2.5, available memory 6.2, we have disk TU 0.05. For the 15 minutes usage test, we will open Chrome, so and so, check Windows setting, open and close File Explorer a few times. Is this enough variety of actions? And should I note down exactly what I do to each action so we can correlate it with the performance later? Data later. So excellent thinking about correlating actions with the data. Test our test plan with a structured activity log. Is this enough variety of action, and should I note down exactly when I do each action so we can correlate it? So he's trying to these steps to be done and recorded. Maybe he tried to record this in a log. Let's see what he will do here. See, create an activity log files, activity log function, so he will record also the steps that we are doing, opening a lot of things. So we have log activity action, we have notes, baseline, browser. What is log activity? This is function log activity. So here get date, so and so, add content, so storing actions. What this will do? Here is add content. So what this will do exactly? Log activity. Okay, this is a custom function. Okay, get date, action, and notes. So log activity minus action, start, test, notes, begin baseline. So what this will do exactly? Okay, let's see. Activity log, see performance, out file. Let's see what this will do. Match exact times performance data, see what impact each action has, create better documentation for future reference. Would you like to start your test with this logging in place? So this is, as we see, all of these are steps to just create a baseline, okay, and then begin the repair process. So this is also a good thing, actually very detailed, and actually I don't think uh, I need to do something. I need to make sure that this script is working because I don't see here how we will log the activity. Let's copy and see if analyze this script and verify if it is correct or not. Just a moment. So let's continue, guys. Let's see if this script will do actually something. If I go there, he is saying that that's mostly correct. It works in intended. Writes header. The function takes two parameter action and notes. Well, when called, it pretends current state to provide the action, so and so. Logging led two events, one indicating the start of a test, or simulating the opening of a browser with specific notes. One indicating the start of a test and the other simulating the opening. So I don't know if this can work. If I take it, it will work. Simulate the output. I don't know actually if this will work or not, but we can open like this one and try to see. We do like that and start. Let's see if this will work. Do like that. Use it like this. So what we should do, okay, this is create an activity log, okay, time and action function to log activities, okay, okay, use it like that, log activity, action, start test, notes, beginning, capture. So I don't know, this will, if you do like that, could not, okay, so we need to have this already created. So how this will work, I don't know actually. Log activity, action, start. Okay, let's ask again ChatGPT how to use this script. Let's see how it will give us the way to do that. First, save the script, ensure this is there already, activity.log, okay, verify the folder, log activity, okay, I think here I did it already. I think I need two. So this is like a simple logging, automatic logging or something to record. So for example, I will create the file and then open the browser and then use it and then go and type log activity, for example opening browser, so it will put the action with the date and exactly the same time. Let me show you what he means by that. So for example, first of all, I need to create this location, so I need to copy that. So let me tweak this script a little. Modify to create uh, let's see, to create, let me see that. Or let's tell him to enhance it directly. I think enhance, so I know now what he means. Enhance this script. Let me show you. So I know already what he is talking about. Here is logging each step that you do, but you need first to open the browser, then go to the PowerShell and tell him to log this action. Okay, he will log it as you type it. For example, this is so and so for something, and he will get the timestamp of this action. Let me see here what is the enhanced report here. So directory creation, that was I'm talking about. He need to make sure that this is already there. If we go and see, for example, here, ensure that the target if does not create it, this is the one I'm talking about. I need to copy that and put it like that. So let's remove it and Control A and then do like that, Control C. I will show you guys what I mean by this, but wait for a moment, I will come back. So let's continue, guys. I think I have already known what this script will do exactly, but we need first to save it. File, save as, and save it as log file. Okay, and then we can do like that, and we need to do like this just to make it not executed. Okay, like this one, and make like this one, and now we can apply the script. Let's see, but here there is a problem. This is not allowed, he's saying. If we do like this one, okay, let's see if this will be applied. So now we can go and tell him, for example, log activity action browser node Chrome info, like this. Let me see if I do like this one and copy and then paste, press enter. I think now there is something will be logged in the file. If we go to the C, let me go to the folder. Here is this PC, then we have C, and we have performance data, and we have the activity log. I think now we will have an entry. Okay, so here it is. This is very, very simple. When you begin working with the fresh VM or the clean VM, now we have see here at the timestamp. Now we can play with the notes. So it's just like a regular file. We just only tell him to log our activities in like something like a text file. So this is very, very simple. You just open, for example, the browser and then put this line. It will log it. Just for reference, after that, when you were working with the clean VM, to make sure what you done exactly at what time. Very, very clever from my point of view, and very, very simple script. Actually, I am amazed with the scripting capabilities of Claude and actually the logical thinking. So this is a good thing. Let's see if I try to ask him to continue, because actually I didn't continue the scenario. So now we have all of this was with the clean VM. So would you like to restart your test with this logging? Tell him yes, and then let's see what he will do. So now he will begin the logging. Let's see first. This is all on the clean VM, the first VM. Let's start fresh with logging and monitoring combined. So now we have the performance data. Okay, we will log the things that we are doing. We log activity, set up our monitoring environment, performance data. So we have our activity log. We have seen this one, and then we will uh, start baseline monitoring. Let's see this. Okay, so this is good. He's now even logging his start monitoring baseline. So this will be like a reference or electronic log for all of our activity on the VM. And now we will begin running the counters, and then we will have all now proceed with other activities with your activities. So these are logging the activities of the performance monitor, and then we will log opening the browser and opening Office, then starting application, logging all of the activities. Let me start the activities, let action, open browser, and then we will wait for some minutes or some seconds. Open the Word, creating test, open Chrome, open blank Word file, using applications, browser activity, so and so. Very, very good. I am adding sleep commands between actions to make sure you get clear performance data for each action. Good. It's a good approach. Should I add more variety to the activities? Good thinking with the sleep command. Let me make it even more systematic. Function for standardized testing, test system activity, duration. So he will make it automatically, just to add a function to make it sleep automolog activity, start activity name, note beginning, and then duration. So he's just, instead of typing sleep, he will do this systematically. Every time you type a line, or every time you put an activity, he will wait for 45 seconds before doing the other one. Okay, so counter process, activity, testing system, working browser. So I think this is good. This more systematic approach. Want to try this enhancement? Okay, so now he will add some durations for the logging. He will wait until uh, start sleep until I log. We wait for 45 seconds, and this should be done systematically. So is enhancing his script further. We can see that the script is evolving, not evolving. It's enhanced. Tell him yes. Okay. So we have all of our activities logged now. And as you can see, everything is, this is only on the clean VM. We didn't start the SFC or VM2 or VM3. We are still working with VM1. Okay, so if we go there, let's see the answer. If I go and continue with the answer, so now he's enhancing his script. Run the function setup, then log activity, then run the performance snapshot, then now running the test, the browser, the office, so and so. I see each activity is being logged with its performance metrics now. The CPU seems to be a spike a bit when opening Chrome. It is normal? Sure, it is normal. And should we add more types of activities? Good observation about the Chrome spike. Yes, it's normal. Let's all more comprehensive activities and capture metrics. What we should do, what we add, we need to add more. I think we don't need to add more. This is our all uh, capture metrics before activity and capture metrics after activity. So this is becoming very, very enhanced. Okay, so it's taking so just to analyze which activity or which process is taking more activity, calculate the changes, and he will give you, for example, the performance before opening Chrome and the performance after monitoring Chrome or after opening Chrome. So let's run more comprehensive tests. Chrome with multiple tabs, Word with Excel and widgets, file creation and copying, Windows. Okay, so it is getting more enhanced. By the way, this enhanced version will show changes in metrics between start and end, track processes, count changes, include idle monitoring. Let's go further with him to see how he will have his answer. Okay, I need to get to the VM2, how we run SFC. All of this we are uh, focusing on things that not related to our topic. Okay, uh, okay, so now he has already run the script, and now we can see this is the output. We have start browsing, beginning Chrome with multiple tabs, CPU. So this will be the output of the script. Okay, here you can see, okay, very, very good. Okay, Chrome caused the biggest CPU spike. Memory keeps decreasing when we run more tests. The process count keeps going up. It's normal behavior. We should consider about decreasing memory. Good observation. Let me analyze the behavior. Chrome high usage is normal on startup because it launched multiple processes. Initialize its rendering engine. Load default decreasing is expected because Windows is caching frequently used files. Applications are allocating memory. It's not concerned unless it drops below 2 gigabytes. For process count, document the baseline before test. Note new processes for each application. Identify source leakages. We like to add more threshold monitoring to alert us. Okay, yes. So all of these we are just preparing the baseline, okay, our baseline performance before using SFC and so on. So he is again modifying the script. I don't know when he will begin working with our so again he is adding the memory. Okay, watching below 2 we probably so and so. Okay, now monitoring the memory. Should we add more switch to CPU usage? Okay, monitoring for multiple thresholds, activity, create monitoring job. Okay, this enhanced monitor multiple metrics simultaneously. Use background job to prevent blocking. Allow customizations. Include disk queue monitoring. Would you like to test, please? Go to the second VM. I think now we have enough baseline metrics, baseline performance metric. So as we see, now he's going to the second VM, and let's see, now we are working with the corrupted VM. Let's see how the answer, I think I can stop at this, but let me first see how he will handle this. So now he's saying yes, let's move to VM2 where we will create our test issue. First, let's review what we have learned from VM1 baseline and set up proper monitoring for our repair scenario. So these are the scenario. First, create our baseline snapshot of VM2 before creating. So now we have VM1 baseline properly set up. Let's review what we have learned from VM1 baseline and set up proper monitoring for our repair scenario. So we use our VM as a baseline for performance. Now we will create a baseline, or we create performance for our performance monitoring for our corrupted VM. First, we create our baseline snapshot of VM2 before we create any issues. Okay, this is the matrices. Then log our initial state. Okay, now we can see that. Then create backup of the DLL file. We have seen this. Logging it, create the issue, rename it, and so on. So now set up monitoring repair process. Then add the content and strip. Ready to create the issue and start monitoring the repairing process. Unit yes, let's do it. Should we also check if any applications are currently using DLL before we rename it? And do we need to stop any services first? Excellent thinking about checking. Yes, this is correct. We need to make sure no one is using this file. So we need to go and see, and then we log this activity and then check Windows services, get services where object is running, log activity service check, currently running services. Okay, so this is one thing. So check process using the DLL, check Windows services, proceed with our previous commands. So I think I can stop at this. So now we have our VM baseline created. As we see, if I didn't tell him to stop uh, making more scripts concerning the first VM, he will continue just making the script more and more efficient. So now we are taking him to our base scenario to begin uh, uh, fixing the issue with our second VM, which contains corrupted file systems. As we can see here, we have a lot of info. We have already as we see, a lot of information, and actually I am astonished from this answer. And actually, if you didn't direct the AI to do what you are talking to him, he will begin working endlessly, okay, until you see that the answer is getting more and more uh, complex. Before that, I need to tell him something. Give me, okay, let me see, junior IT, the dialogue I am getting overwhelmed with the answer with the exercise, with the case. Can I have a summary? What we have done until now with help of interactive elements and diagrams, just to make sure that we can follow the answer of of him so we can follow him. Okay, so let's see this one. So this will be the summarization for what we have been working on for this case along 1 hour or more. We can see we have all 1 hour and a half. So we need to summarize what we have done until now. So let's see here how he will what we have done until now. So we can see untitled. This is diagram 1. Let's see how this is there now. We have virtual 1 machine baseline clean installation, performance baseline monitoring normal usage, collected metrics, virtual 2 which is our corrupted test environment, prepare system, check dependencies, create backup, create issues, monitor repair. So this is our summary until now. If we go and see the other diagram, so let's see this how this will be. We have our this is our second VM. We can see we have backup the DLL. Okay, then we create the issue, then we will run SFC. SFC fixed, yes, verify the system, no, run DSM, run SFC again, verify the system, compare performance. So very good. Now in the upcoming video we can begin our scenario again, or continues our scenario. Now we have what we will do in VM. So let's see where we have stopped. So I think here we have already done step 1. So now we have already the script to do everything. Now we have everything. Okay, so I think we can stop at that one, and then he is asking if we can begin with we have done this already. Step 1, check for process, monitor state, then create the issue, rename the DLL, simulate the corruption, expected. So here what we will do in the upcoming video, we need to do this, and just this is like an explanation. Now he is talking about, let's break down we have done and where we are. Completed steps: VM created clean Windows installation, collected baseline performance, monitor normal stages, normal usage, document typical resource usage. VM2 ready to create our test issue, about to monitor repair process. 3 key metrics we are watching: CPU usage, memory usage, disk activity, trusted installer behavior. Would you like to explain any part in more details, or shall we proceed with creating our test issue in VM? Okay, thanks. The diagram helps. So we are done with VM baseline, ready to break things in VM2. Would you remind me what exactly we are going to do in VM2 and what we expect it to happen? So I think this is very good. We will stop at this point and continue in the upcoming video. Hope this video is informative for you all, and thank you all for viewing. Thank you so much.